All right, 133. So this, and it said find domain of the function, horizontal asymptotes, vertical asymptotes. It could ask you for your zeros, your y-intercept, like you want to be prepared for all that stuff, okay? So 133, the first thing you're to do is take out the 2 in the top, and you get x minus 5. And then in the bottom, you're going to factor, and you're looking for factors of negative 15 that sum to negative 2, so negative 5, positive 3. And then before we cancel out, we do domain. So it can't equal 5 and it can't equal negative 3. So negative infinity to negative 3, negative 3 to positive 5, and positive 5 to positive infinity. Then you cancel out if you can. So in this case, x minus 5 is in the top and the bottom, which means there's a hole. And the x coordinate of your hole is 5. And then everything else, we use the updated function to find. So I would take that 5 and plug it in. I'd get 2 over 5 plus 3. Or 2/8, which is 1/4, and that's the y coordinate of your hole. And then vertical asymptote, set my denominator equal to 0. I get x equals negative 3. And then horizontal asymptote, the exponent in the top is smaller than the one in the bottom, so it's y equals 0. There's no slant. And there's no zeros because 2 can never be 0. Everything's the new one except domain and the x coordinate of your hole. Everything else after that is the new one. And then y-intercept would be 2 over 0 plus 3, or 2/3. So then when you go to graph, you've got a vertical asymptote at negative 3. You've got a horizontal asymptote at 0. No zeros, a hole at 5 and 1/4. So 1, 2, 3, 4, 5, and 1/4 means we're above the x-axis here. And then the 0 being, or the y-intercept being at 2/3 is consistent with that. So it'd be like that. And then they're typically opposite corners unless it's got an x squared in it, okay? But I would also, if this was me and I was taking a test on this, I would certainly plug in a point from that left-hand side to make sure I knew where I was going. So I'd plug in like negative 4. So 2 over negative 4 plus 3 is 2 over negative 1 or negative 2. And now you know for sure you're below the x-axis. Other questions from 2.6 or 2.7? There's a lot of graphs on here for you to practice. Like, trust me, I worked them all out, okay? But it could be any of these scenarios, so you got to be prepared. It could be vertical with horizontal, vertical and slant, a hole, 2 vertical. Like, it could literally be any of those combinations, so you want to make sure you know them well enough that you're comfortable doing it. Correct. You can't have both. You could have neither, which isn't typical, but it exists. But you cannot have both a slant and a horizontal. Yeah. No, not this one. Yeah. The interest word problems, your exponential problems, like, you know, find if 3.2 times 2 to the negative x whatever, and then plug a value in, like that kind of thing. And then the interest word problems. Continuous, monthly, daily, whatever it is, you got to be prepared for those. So those 2 formulas. Nothing else on 2.6, 2.7. How about 3? So 3 has your exponential graphs. That obviously would not be on the calculator portion, but something like this would be calculator based. And then your interest word problems or a word problem like this would be calculator based. The rest of them you need to either have the one-to-one property like 81 and through 86, that's your one-to-one, or the graphing of your exponential function. And the graphing of the exponential function also does like the domain, the horizontal asymptote, the t-chart. So you got to be prepared for all that stuff. Yep. It said 4 decimal places that time, right? It was 0.0001, I think, right? If it was just 3 decimal places, then it rounds to 0. But because it said 4, that 1 stayed. Feeling confident? Yes. We're excited to take a test because we're going to do well on it, or we're half asleep. As you yawn. Perfect timing. Okay, you're going to do, so good question. Remember, a horizontal asymptote, it can affect the ends of your graph, but if there's two vertical asymptotes in that space in between, it can touch that horizontal asymptote. So this time it touched it, it could cross through it. This one, oh, did I graph that? That should be it. I think I changed this question and I didn't change the answer key. It should be at 0. This should be 0. Or did I just write down the wrong one? All right, so this is your function. The exponent in the top is 1 more than the exponent in the bottom, so you know there's slant. There's 2 ways to find slant: divide using long division or divide using synthetic. Because it's x plus or minus a number, and only in that scenario can you do synthetic. So I would have done synthetic. So the -1 goes on the outside, and then you list your coefficients. So 3, 5, -2, bring down the 3, multiply it by -1, put it in the next column, and add it. Multiply it, put it in the next column, and then add it. And this we ignore. We totally ignore the remainder when you're doing your slant asymptote. So your line is going to be 3x plus 2. So y equals 3x plus 2. And then when you go to graph that, it's already graphed there, but on the graph, I would go to where my b is 2, and then I count my slope up 3 and over 1. So 1, 2, 3 over 1, or down 1, 2, 3, and left 1, either way. There's your slant asymptote. And then you had a vertical one this time at -1, right? So now I know it's in between those corners. It's either going to be here and here, or it's going to be here and here. And because you had zeros at 1/3 and -2, I knew to choose those 2 corners. Other questions on any of these? Oh, so the next page. Anything else on that one? On this page before I go to the next one? Going once, twice. Okay. Number 11, you said? Yeah, 11. Okay, so you've got g of x equals 6 to the -x plus 1 minus 2. So first of all, if I were to compare this with my initial parent function, the minus in the exponent is going to be a flip over the y. And the plus 1 would be a shift left 1. And the minus 2 would be a shift down 2. So if you graph it and then flip it, obviously then the left side would end up going to the right side. But I would just say you're going to plot some points. I'm going to give you a T-chart. You're going to fill it in. You can use the same 3 points that we've used every single time, -1, 0, and 1. And you're going to plug them in. So 6 to the -1 plus 1 minus 2. 6 to the -0 plus 1 minus 2. And 6 to the -1 plus 1 minus 2. And then this becomes +1. So +1 plus 1. This is 6 squared minus 2. 36 minus 2, which is 34. This is 6 to the first minus 2. So 6 minus 2, which is 4. And this is 6 to the 0 minus 2, which is 1 minus 2, or -1. So then when you go to graph, and I'm going to give you the graph on your test, but obviously 34 is not going to be on that graph. So when you do -1, 34, you could just simply go off your graph and then plot it, like -1, 34, label that point. Then 0, 1, 2, 3, 4, and 1, -1. So your horizontal asymptote, which you have to be able to identify, is down 2. So there's actually a horizontal asymptote that runs through y equals -2. And then that's how I know to curve and bend your function. So you want to make sure that you have to map, and you have to draw that horizontal asymptote on your graph in order to get the shape of that curve. What's the domain of that one? All round numbers. What's the range of that one? Good. Does it get a parenthesis or a bracket? Parentheses, because we don't include it, right? And then your y-intercept is that middle point, so it would have been 0, 4. So those kinds of questions can get asked about all of those exponential functions. Yep. Whatever that vertical shift is. So if it's up 1, it's y equals 1. If it's down 2, it's... So this is the first one. this one had a hole. So before the hole, the very first thing I did, factor both top and bottom. And then before you cross out, you have to do domain. So domain comes before we cross out for the hole. And it's negative infinity to negative 1, and negative 1 to 1, and then 1 to positive infinity. I think almost everybody got that right. So good job. Then it cancels out, and it cancels out at x plus 1, which means the x coordinate of your hole is negative 1. You have to plug it back in to get the y coordinate of your hole, and you have to graph it. So when you plug it back in, which you plug back into the updated function, so domain and x coordinate of your hole come from the original. Everything else after it comes from your updated, which is at x minus 6 over x minus 1. Then I plugged the negative 1 in and I got 7/2 or 3/2. That has to be graphed. That's your hole. Then you get your vertical asymptotes from the denominator, x equals 1. Your horizontal asymptote, this time they are the same exponent, so it's your leading coefficients, which is 1. And your 0 comes from a numerator, which is 6. There's no slant, and the y-intercept was 0, 6. So then I literally plotted that stuff, and it was enough to know what my shape was. The y-intercept above helps you know it's above, and the hole here obviously tells you that that curve is crossing through there. And then the 0 on the right-hand side told me to put it underneath the curve there. So I didn't need additional points this time. This one got a little weird, okay? First of all, your zeros are at or your asymptotes were at negative 1 and 1. So it's hard because those points are going to have to be a fraction, okay? I tried not to do it on your test. I haven't even made the makeup, but I tried not to do it on the test. But if you are that close together and you can't find another point, you're going to have to plug in fractions, okay? So just be prepared that I would make sure I know exactly what my graph looks like. Don't try to guess what it looks like. What was weird about this one is that your horizontal asymptote was at 0, but you also had a 0 at 6. So it can cross through. I don't know why it's not letting me right there. You can cross through your horizontal asymptote. The horizontal asymptote affects the outsides of your graph, so it determines like that where those arrows are pointing. But it can cross through it. It can't cross through a vertical one. So then in the middle, I literally plugged in negative 1/2 and positive 1/2 because this is not symmetric, so it's not a given that they would be the same. And they both pointed up, which meant that took on that parabola shape, and if that happens, the other two curves are going the other direction. But I also plugged in, I plugged in negative 2 over here, and I plugged in positive 2 over here to see for sure where those curves were going. Be prepared for a slant, too. Obviously, there were slant questions on your review. You could get a slant on your test, okay? So make sure you know how to do that, too. And then came your exponential function. So this one, I'm going to plug into my t-chart, negative 1, 0, and 1, and identify your horizontal asymptote, which is wherever your vertical shift is. So because this is down 3, my horizontal asymptote is y equals negative 3. Do not forget your y equals. You will lose points if you don't give it to me in equation form. And then I plotted the other points, and I drew it out. Domain, all real numbers, range negative 3 with a parentheses to positive infinity, and your y-intercept came from your t-chart. Okay, in addition to these, you still have your one-to-ones, you still have your calculator questions, you still have your interest questions. So make sure that you've done that PDF in its entirety, okay? But you should be okay.